Before we continue with the video, if you like what I'm doing here on this channel, please consider subscribing. It helps the channel a lot. Anyway, let's get back to the video. So this is essentially what we will be creating today. We will be taking a look at how you can animate your skeletal meshes that are sort of like vehicles, like the Vigilante example assets or any other vehicle assets essentially, and show how you can make them come alive and make the animations or have their skeletal meshes affected so that they look like they are alive. And in this case we are just creating a simple rotation for our rotor here. So if I press down a key, you can have the rotor which will be spinning up until it gets to a max speed, and I can at any point also just release the key and it will start spinning down again. So that's what we will be trying to achieve today. Welcome. In this tutorial we are going to be going through how you can make use of a vehicle, for example, that has a skeletal mesh, and see how you can make them animate. So in this particular instance we're using a Vigilante asset, so I'll show how it's done on that, but this works on any kind of vehicle or object that has a skeletal mesh essentially that you want to animate, if you want to understand how that works. Normally you would have a character, and the character would have a skeletal mesh, and you would have some animations and you would just make use of them. In the case of this, we don't need to have an animation, we can animate just by having the skeletal mesh itself. So in this case we have a helicopter here, which is one of the showcase levels for this Vigilante asset. And going up here in the outliner we can open up the blueprint for this helicopter. And this helicopter is set up with a bunch of different interfaces that it can make use of. This is so that it can be used as a display object for the level. But it itself is inheriting from another blueprint which is called Heli over here. So this blueprint is the actual blueprint for the helicopter base essentially. And this is what we will be making use of and looking into and manipulating a bit, so hopefully you can get an understanding of how you can animate vehicles and such in this way. So let's break this down into small simple components. Let's start off with going to our skeletal mesh over here, and by clicking on the magnifying glass we can find the skeletal mesh and we can open that one up. So this is our skeletal mesh, or our mesh with our skeleton. And you can see here that we have a bunch of different bones that we can make use of. And how this works is essentially each of these bones, if we were to click on something here, you can see we have the ability to manipulate. And for certain vehicles, in this case the helicopter, it makes sense for certain bones to do certain types of manipulations more than others. If we were to click on the rotor main JNT here, for example, it is the bone that corresponds to the main rotor around here on the helicopter. And in this case, if we were to say rotate this bone around the Z-axis, you can see that we get a rotation for the rotor itself. And this is how we can make use of the bones to animate something. Because we have all of these bones available to us, we have complete liberty to use any of them in any way that we want to. It can be, for most part it will be rotations, like changing the turrets or turning up wheels and things like that, but there could be some things that actually just move in a local space instead of rotating. But in this case we will be focusing a bit on the rotation parts. So we will essentially be making some code that allows this to happen so that we have the helicopter animating in a sense where it looks like it's about to take off. At first glance it might be a little bit difficult to see which ones of these are of interest or not. So what you can do is you can go to character and bones and select all hierarchy. This means that it will display all the different bones that you have available to you, and you can see which are the ones that are most likely going to be of interest. You can see which ones are the likely ones to have a possible rotation to make it look like it would be interacting with the real world. So that's something that you can do. So that's the first thing, understanding that the bones are here and we can manipulate them. So how does it actually do that? Well, going back to our blueprint here, let's close the one that has all the interfaces in it and stay to the the main one. If we were to go, yeah, like this one. So controls the speed of the main rotor. What are we doing here? We have a function which we can call at some point, and we can set a variable which is called main rotor speed. Main rotor speed in itself is being used as an input to the anim instance and setting a variable over there called main rotor speed. So what does this mean? Well, this means that the anim instance for this object, which is in this case is the skeletal mesh, has an animation blueprint here. And this animation blueprint, we're saying set main rotor speed to something in it. So if we open up this animation blueprint over here, this is what it looks like. So right here we can see there are some things for stabilizer, turrets, flap, wheels, and wheels. Let's see, do we have any rotors? We have rotation data for wheels, it says. But it actually has the main rotor speed here, which is the variable that was being set here, main rotor speed. So what is being done here? Well, essentially we have a variable which is currently set to 0, which is being multiplied by the main rotor speed, which is set to 0 by default. This is going to be changed in runtime, of course, and then multiplying it by a negative number, and then it's saying essentially use this as the Z value to set a rotator over here. So this is just another variable which we have a rotation. So this will be a value between 0 and 360 if you're using degrees. And if you were to have a value above 360 like 720, that's essentially just 360 times 2, so it would be 360. So it's essentially just rotating around its axis in complete circles. Now, this main rotator itself, we can just right click and say find references, and we can see that it's being set somewhere, and that is over here, and we can say that it's being get somewhere else. Clicking here, we can see where it is actually being used, and this is the updating of the animation graph, where it gets its pose from. If we were to go to the right here, we can see here we get the output pose. So here you can see we have a bunch of different transforms of bone, which is essentially what we did when we were rotating it over here with the bone, but being handled in the animation script instead, or animation blueprint. And it's very easy to create these. All you have to do is right click and you type transform bone, and you get one of these nodes. And then you can see that it handles an input pose, so you would just hook it like so, and the output pose you just hook to the next part in the chain if you want to have multiple ones. And then you can see that you have a translation, a rotation, and a scale that you can set. So the rotation here is being used as the value to set what the rotation of this bone is supposed to be. And this node right now is not actually linking to any specific bone. If you look at these transforms, you can see that it has a bone variable set here, rotor move JNT, which is exactly the one that we were moving around over here in our attempt to visualize what we're trying to do. And how to set one of those is you open up this node here, and you can see here the bone to modify, and you just pick the bone that you want to affect in some way, essentially. So that's how one of these is actually set up. So hooking this back up again and removing this node, we now should have a pretty good understanding. What we're doing is we're rotating a bone, and this is done by sending some kind of value to our animation blueprint, which in itself is, let's see, over here. Taking that value, and every frame it is updating and saying that my rotation for my rotor should be something, let's call it X, and then that is being used over here to determine how that is actually looking on the model itself. So that's the whole flow of it. So how can we make use of this? Well, let's go to our animation, no, not our animation, our blueprint again, and let's actually make this usable. To start off, we can see that this helicopter is currently inheriting from a actor. You can see actor over here. And if we wanted to make use of this helicopter in our game and we wanted to actually play it, we needed to have it as a pawn so we can actually take control over it. To do that, we can go to File and Reparent Blueprint, and we type in pawn, and now we should be able to control this helicopter theoretically. However, in this case, we have now currently the showcase mesh or blueprint for this one. So what we want to do is we want to click on the blueprint that we have right here, which is the parent of the showcase one, and we'll say that we want to browse to it. And then while having it selected over here, we want to right click on the helicopter and say replace selected actor with this helicopter. So now this one will be the helicopter that we have actually made into a pawn. We can see that by clicking on this blueprint link, and it should be opening up the blueprint that we have been messing around with currently. To test that this is working, we want to add an event, let's say keyboard1, and from this we'll just drag out a print. So we'll print string a hello if we press the 1 key. And this should happen if this helicopter is being controlled by us, because pawns also pick up input. So clicking on this helicopter again, we need to type in possess. You can see here I have already typed in possess earlier, or pos. So auto possess you want to set to player 0. And by having player 0, that means that if we start playing, it should be automatically taken control of by our player controller. So we click the selected viewport, and you can see we end up under the helicopter. So we now have control over it. Pressing the 1 key, we can see that nothing is happening. So let's check what that is all about. If we go to our world settings, we can see that we have a HUD class called show visible. This is related to the level that is created for this. We wanted to choose the normal HUD class, which doesn't have anything in it, because this one will likely be conflicting with us. So let's click play again. Pressing now, you can see we get our hellos here. So now we have properly control over this helicopter. Let's create a camera for this one so we get something we can see from a different angle. So we'll go a boom. It's not called a boom. Camera. We want the camera, and we want to have, it's called spring arm actually. Spring arm, like so. So we'll put the spring arm under the skeletal mesh. No, not like that. We undo that. We want to have it. Oh, it is under the skeletal mesh already. That's good. So we want to have the camera under the spring arm. And then we can either control it with the spring arm information, saying like, I don't know, 600 back, maybe even further, 800. We maybe want to position it a bit, something like so, and maybe have it as an angle slightly looking downwards or something. Let's say we try that one. So if we press play now, this is what we see. So you can tweak around with the variables to get something that you like. But essentially, now let's do some functionality that actually drives some animation that we want to create. So we'll go to our blueprint again and go to the event graph. The very first thing that we're gonna do is we're going to be this event currently, we'll just unhook it so that you know that it's not actually working anymore. So the main rotor, we shouldn't be getting a rotor speed, but we'll also be going into our animation blueprint, and we'll find in the event graph the update rotor speed here for the wheels and everything like that, and we'll just disconnect that as well. So now we don't have anything that should be updating the main rotation, because this is the only place where it's being set, and we are now currently not setting any information for it to update with. So we will be driving all of this functionality in our blueprint just to make this easier to grasp. So let's go back here. We can remove this debugging that we had, and let's start making something. So let us work backwards. We know that if we go to our animation blueprint, that if we set the main rotor rotation, it's being updated here per frame, but we have disconnected any functionality of it actually being set currently with disconnecting these nodes. So we can actually make use of that. We can say that our animation instance over here, we want to update the rotor directly. Now we can't do that because in our animation blueprint, if we go to the main rotor rotation over here, it is set as private, which means that we can't access it from other blueprints. Since we're doing this, they've done this to protect the variable from being accessed from outside, but we're doing this to learn and understand how this works, so we'll uncheck the private so that we will be able to have access to it. Going back to our blueprint now, we can say set main rotation rotor, or rotor rotation. And you can see that we have access to this now. If we right click and split the rotator, we can see that these are the float values that we have to work with. Now, how we want to do this can vary, but what we will be doing is essentially we will be making a event which will work sort of as an ignition, and once it's started it will start to rotate, and then it will rotate faster and faster until it has reached its top speed, let's say. To begin with, we can just do something a little bit simpler just to see that it works. To do that, we will start off by right clicking on the Z, and we'll say promote to variable, and we'll say it'll get default main rotor rotation yaw here as the name, which is perfectly fine, and it will have a default value of 0, which is also perfectly fine for us to begin with. We can right click and add another event, keyboard, let's use the 1 key again. We can say that what we want to do is we want to take this value and we want to add a value to that one, and let's say we want to add, let's take 20. And then after we have done that, we want to set this value, so setting the main rotator to be this new value that we have just managed to get. And then after that we say set in the animation instance that our main rotor rotation for the Z should be this value, which we have now just added to. So this should mean that every time we press the 1 key now, our rotor should be rotating 20 degrees. So let's play, and we can see that pressing the 1 key does exactly that. Now you can see here, technically this is rotating in the wrong way, which is why they had the multiplier -1, because according to how the fins are, it's supposed to rotate in the other direction. But that's up to you to fix that if you want to. This is mainly for understanding how this works. So now we know that we can actually affect the rotator from outside. So how would you actually go about making something like the ignition that we spoke of? Well, we can make use of something called a timeline. For example, there are many other ways, but adding a timeline allows us to rotator rotation, I'm going to call it. And we can just say that once we press 1, it's supposed to play. And what will happen inside of this one, we can say we want to have a new track, we can say we want to have a float track, and we can say that this is the rotation percentage or something like that. And on this one we can right click and add a key, and then right click and add another key, and we can click on the first one and say at time 0 we're supposed to have a value of 0, and then we click on the other one and we say at time 5, since the length of this one is 5, we want to have a value of 1. And clicking on these two to zoom to fit, we can now see what that curve looks like. So this will be our curve. We will be going from 0 to 1 over a period of 5 seconds. Everything is fine so far. What we want to do is we want to make use of this value which we get out, which is this percentage here, and use that to drive our rotator. Since this will be going between 0 and 1, and let's say that we wanted a full revolution of the rotor to be what happens once we have reached the 5-second mark, we want to multiply this value with 360 because of 360 degrees. So like so. And then we could actually hook this directly into our main rotator like so. And make sure that our update runs into this one. And we can remove this. So this means that when the timeline gets called, it will start updating, it will go through this timeline, and every update it will run through and update this rotation like this. So let's see what that looks like. So we press 1 and you can see that it spins around, and it will do a full revolution in 5 seconds now. And that's all good and fine as a start, but it doesn't continue from there. Now there are many ways you can solve this in. You can have it on a tick, you can have it on a timer, or you can just make use of this timeline if you wanted to. And on the finish event here, we could add a reroute just to make it clear what we're doing. And then we can drag this to the play from start. Now you might be wondering, why do we choose to play from start? Well, the play will resume this timeline from wherever it is currently on it. So if it was like the rotation was partially done, it would continue from that timeline and then update from that. While on finished, we're essentially saying that once it has ended, it should start playing from start and not from where it is, because it is at the end. And now it should essentially be playing the rotor multiple. That's the wrong key, sorry. There we go, sorry, wrong keys. All the wrong keys, pressing one, let's rotate. Okay, so 3/4, 1 revolution, and it still continues to spin. So now that theoretically works. This is one way you can go about doing this. And now you can have it as so that this is being controlled by some sort of speed as well. So you can add another float here, and you can say that this one is supposed to be the speed. So if we promote this to a variable, we can say that this is supposed to be our, let's call it rotation speed. This will dictate now how fast this will be running. So if we have it like currently we have 0 as default, if you press 1, nothing will happen. The rotor won't start spinning at all. If we instead had this as value of 1, we would have the rotation that we had before. As 10, it would be going 10 times as fast. So now it should be going 10 times faster. So that's how you can manipulate that. And now you might be thinking, well, how do I change this then? Well, you can have this as a curve if you wanted to, because this rotation that we have over here is essentially a curve. If we go in here, this is a curve. So this in conjunction with our speed could determine our end speed. How I mean this is, if this rotation speed is our maximum speed, let's say, so this is the amount of revolutions that we get as maximum, and we're happy with that. We can now make use of our, sorry, over here, our curve over here to determine that it should be winding up in the beginning, for example. So if we right click and add a curve, a key here, and we were to do something like this, and drag them out so it's a little bit steeper in the end, like so, you can see that it should be fairly slow in the beginning until it gets to the end. So let's see what that looks like. Now you can see that it starts slowly, and then it spins up, and then it goes faster and faster, and then it's really fast in the beginning. However, now you can see that we start off from the beginning. Again, if we go back here to our timeline, you can see that we're playing from start once we have finished. So this is of course now being contradicting to what we wanted to have, because once we have reached the maximum of this curve, or once it has essentially started up, we don't want it to slow down in speed. So let's build upon this a little bit, and let's say that when we press down the 1 key, it will start to rotate until it gets to the full speed, and if we release it at any point, it will stop. So what we want to do here is essentially, first of all, we can get rid of this connection here, and we can say that we instead want to promote this value here. So we promote this value to, let's call it percentage throttle, I guess. Something like that. So we'll update the percentage throttle whenever this updates. And instead we can disconnect this and say we want to move this over here. And we can say that we want to update this on tick instead. And we do this because it's fluid and it's going to give us a smooth animation for our rotator. So we want to use this percentage throttle now as our value in here, just like before. So it will be going from 0 to 1, and Once it's reached the end here, it has the value of 1 set, and then that means that we have our full power essentially, which means 1 times this value. But we don't want to have a rotation like this now anymore. Now we instead want to make use of our delta seconds to see how much has it rotated since the last frame we essentially updated. The problem with this is that now we have a delta done. This is essentially going to give us a fixed value, or it might vary a little bit depending on the delta seconds. But this is essentially a delta that we want to add upon something that already exists. So we want to actually get the rotation from here, just so we can make use of what is the last position it had. So we break the rotator. Now we have the last set value it had over here, and we can add to this one the value that we have calculated here, the delta essentially, and then we can make use of that to send it in here. But in addition to that, we can also do something in addition, and that is we can drag out from this and we can type in a percentage sign, which gives us a modulus. A modulus is essentially going to be making sure that everything is within the range that you give here. So if we put 360, we can say that it will have a value between 0 and 359, and once it gets to 360 it will essentially start over from 0 again. So our calculation goes in here, and we will always have a value between 0 and 359, which will represent our degrees on this essentially. Now, since we're using delta seconds here, this will be a very low value and won't actually spin that fast, I believe. Let's actually give it a try and see what happens. So I press the key and it's just barely moving, you can see. So let's try a higher value. Let's try something like 3000. And let's see what that looks like. So press 1 and it starts off, and it builds up speed until it has a very high speed. So this is the max speed now for our rotor, and it's fine, and it's working as an ignition, which speeds up. But let's say we wanted to have the speeding down as well now. That means that we can have on our our released here, we can do the reverse. Reverse here means that it will reverse from wherever it was. So if we only held it down so it was like halfway through, it will stop from the halfway through and go down towards 1. So let's see what this looks like. I hold down 1 key, I let go, and it slows down. I hold down 1 key and it starts spinning up, and I keep holding it down, and you see it spins up to the max, and then it continues like that at max speed, and I let go and it starts slowing down again. So this is how you can approach essentially doing animations. It is a very simple example that works on pretty much everything, because for a helicopter most of the things will be rotations. You will have your tail rotor over here, it will be spinning or rotating. You have the main rotor, which we have shown here. You can have your gun here, which could rotate upwards and downwards according to, let's see, is this right angle? That's not the right angle. Is this the right? I want this bone. So you could rotate the turret. You can do the same with the wheels over here. Let's see if I can hit the wheels properly. So you could fold them. No, that's not okay. Yeah. Anyway, hopefully you get my idea here, and it works the same with like cockpit windows and stuff like that. You can open these up. Let's see if we can get one. So you can open up a window like so, and you can have your different limitations, like what kind of degrees you will allow it to open up to and stuff like that. So essentially you can use this kind of technique to anything. Now this became a little bit of a more advanced example because we wanted to have some functionality for like spinning up and slowing down, and this is something that you want to keep running all the time once you actually are spun up for the rotor, unlike something like the door, which you would only like rotate with a timeline until it's done, and then you're done, and essentially that's it. So you don't have to have it on a tick, because normally I advise against using tick, but this is one of the cases where you might want to have it running essentially, with some limitations of course. So yeah, Hopefully this was helpful and gave you some insight into how you can make use of the Vigilante assets or other skeletal mesh assets as well. Keep on learning. Take care. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.